Hey everybody, I hope you're doing well today. All right, you are getting this handout which looks very similar to what we did yesterday. Okay, if you will, please pull out your notes from yesterday. Okay, and I would like for you to check your graph for the last function that we worked on. Okay, as well as I would like for you to check the problem that you were supposed to complete for homework, okay? So take a minute, kind of check over things. If your values in your table are not the same as mine, that's okay. That's not a big deal. That's not what I'm ultimately looking for. I'm just making sure that your graphs are looking okay and also checking your characteristics. Let me zoom in so you can see these characteristics real quick. We pretty much had done all these characteristics together. You just had to do the graph. Okay, here's a close-up of that graph. I didn't plot that many points on this one. You don't have to plot that many. Just make sure you plot enough so you see the behavior of your function, okay? All right, now over here, this last one, here are my characteristics. Hopefully you had an opportunity to check over those a minute ago. Okay, and just to compare it to the graph, my vertical asymptote should have been at x equals -3. My horizontal asymptote at y equals 1. Domain and range, check over that. Remember, these are kind of connected, okay? This pretty much is telling me what to write up here for my domain. Same thing for my range. And then I just sketched some points, okay? So hopefully you did pretty well with that. You're going to get some more practice with this today. And this assignment is actually going to be taken up for a grade, okay? So make sure you do it, not only just to do it, but make sure you do it with excellence, okay? All right, so here we go. The very first thing that I want you to see on this particular problem is how very simple it looks, okay? There's not much going on. There's no pluses or minuses or anything crazy. This is actually what we call our parent function. So if you will, out to the side, write that. We know that this function right here, 1 over x, is the most basic rational function that I will deal with, okay? So, the way I go about doing this is no different than yesterday, okay? It's actually a lot simpler than yesterday. The very first thing I'm going to do, as always, is to find my vertical asymptote. Well, I do that by setting the denominator equal to 0. Well, if I set x equal to 0, that's it. X equals 0. There's nothing to move around. So I'm going to come right here. X is 0 at the origin. And I know that that's going to be a vertical asymptote, so it's going to go up and down. And I want to make a note that this right here is technically the equation for my y-axis. Okay? All right, the next thing I like to do is my horizontal asymptote. Okay, this is the Bobo Bots eats DC. Bigger on bottom, 0. Bigger on top, slant. Exponents are the same, divide coefficients. Well, I'm looking up here at this function, and I don't even see a variable up top, okay? So right here, I do know that this x has a power of 1. What I want you to understand, though, is that there is a variable up top, but it's kind of just imaginary. It's technically x to the 0 power. If you think about it and think about the exponent rules, any number raised to the 0 power is 1. Okay, so that's where this 1 came from. All right, so I'm comparing my exponents. I have 0 on the top and I have 1 on the bottom. So where is it bigger? Is it bigger on top or bigger on bottom? It's bigger on the bottom, okay? Bigger on bottom, 0. I'm gonna write the bobo down here, and I'm gonna put a slash through that last O because I wanna remember that's 0. Y equals 0. Well, y equals 0 at the same place x does. This is going to give me a horizontal dashed line, which we call those asymptotes. This actually falls on the x-axis. Okay. Domain and range. The domain is connected to the vertical asymptotes. It can be any number except 0. And my range is connected to my horizontal. It can be any number except 0. It's never going to touch those places. So what I want you to think about, if it cannot touch the x-axis, is it possible for me to have an x-intercept? If there right here is an asymptote on the x-axis, it's not possible for the graph to touch the x-axis. So I'm going to come over here to x-intercept, and I'm going to write none. Well, if I look here for my y-intercept, I've got an asymptote on my y-axis also. It is not possible for that graph to touch the y-axis. So I'm also going to write none. The only thing left to do is to graph the function. So I'm going to turn on my calculator. I'm going to go to y equals, and I'm going to clear out anything that's there. Now, this one is very simple to type in the calculator. My function is just 1 divided by x, so I'm just going to type that. 1 divided by x. 1 divided by x. And if I hit graph, I'm going to see those two little curves, but they're very close to the origin, okay? I'm going to go to my table, second graph, and my asymptotes were both at 0. If I look here, I see when x is 0 that it's giving me that error, okay? So when x is 0, that was my vertical asymptote. I'm going to plot the stuff around it. I've got negative 0.5, negative 2, negative 1, negative 1, negative 2, negative 0.5. Those 0.5s are just 1/2. Let's see if I have anything else pretty. Not really. They're getting really tiny. Okay, so here we go. On the other side of the asymptote, let me arrow back down. Okay, I have positive 0.5, 2, 1, 1, and then I have 2.5. All right, so let's see what this gets us. -2, -0.5, so about halfway down. -1, -1, and -0.5, -2. Now, that's not many points at all, but it's okay because it's going to give me enough so that I can get that little curve. Okay, then I'm going to come over here to the other side of the asymptote, and I'm going to plot 0.5, 2, 1, 1, 2.5. Again, I've got enough to give me that little curve. There we go. There is that function. Okay, so you're going to get some practice today, but just to point out a couple of things on this next one, okay? The very first thing, as always, that we do is our vertical asymptote. If I set the denominator equal to 0, I end up with x equals 1. I'm going to plot that vertical asymptote. And then I'm going to look for my horizontal asymptote. Bobo Bots eats DC. Okay, I have x to the first power on the bottom, and if I refer back to this one, if it's just a number, technically it's x to the 0 power right there, but this x to the 0 power is really just equal to 1 anyway. So 1 times -2 is just -2. My exponent is bigger on the bottom, 0. That's the Bobo. So y equals 0. That right here, my friends, is a horizontal asymptote. So left to right. There we go. All right. All right, so what I want for you to do, I want you to complete this, okay? Referring back, just a little hint, especially for this problem. The rest of these problems on the front and the back, okay, they are very much like what we did yesterday on our notes. So please use your notes to refer back and forth to help you through this, okay? Just a little hint. If I have an asymptote on one of my axes, either the x-axis or the y-axis, the graph is not going to touch there. So there might not be an intercept, and that's okay, all right? Don't stress out if you're not getting one, okay? All right, so complete these problems on the front side. Okay, then you're going to flip it over to the back, and you're going to do the same thing here, okay? Now, if you will notice, I have a boo-boo, and there is no coordinate plane. But what I want you to do, I want you to sketch a coordinate plane. It doesn't have to be super pretty, but at least do your little tick marks, draw your asymptotes, and then sketch your function, okay? Good luck, and let me know if you have any questions. I'm next door, and I'll be here after school, okay? Have a great day. Bye-bye.